Hi, I'm now at the Grand-Teton. You can see the mountain with the snow behind me. And right here is a dam. And the dam is for Jackson Lake. Originally, Jackson Lake is lower, and so they raised the water level by something like 10 meters tall. And what you see here is that the water is discharged from Jackson Lake directly into the Snake River downstream. It's pretty loud. We are at about 200 meters away from the dam. And what you can see here is that water is really rushing out at a very high velocity. And let me just do a calculation here. For that 10-meter drop, if you look at m times g times h, where m is 1 kilogram, g is 10 meters per second square, and h equal to 10 meter, you would have 100 joule for 1 kilogram of water to drop that distance of 10 meters. So if you think about 100 joule, that has converted entirely into kinetic energy, 1/2 mv squared. And you do a calculation, you basically would find that the velocity 1/2 mv squared equal to mgh would give you a velocity of about 15 meters per second. Now at 15 meters per second, you're talking about more than 50 kilometers per hour sort of velocity, a good more than almost 30-some miles an hour sort of velocity, and the water is coming out at that very high speed, which we're going to see a little bit later at the top of the dam. So here, what we're illustrating is the conversion of gravitational potential energy into kinetic energy, and it's very much like what we saw earlier, when water drops in the waterfall, it acquires a vertical velocity. Here, what you have is the velocity, instead of going down, is directed horizontally out. And that is pretty powerful. With this volume of water, which is probably higher than what we saw at the Yellowstone, this would produce way more, probably close to a megawatt of power if this is to be used to generate electricity.